I'm delighted to have Daniel Ye talk to us today from University of South Florida about some really cutting-edge technology on the wastewater side. So, Daniel, thank you.
Okay, I want to thank Deb, NYU CUSP, and also NSF for having me today to share some information with you. So I want my talk to be memorable to you. You've heard so many talks today. So I thought, how can I make my talk more memorable? And I thought, well, if you get hit in the head by a 2x4, you probably remember that. And I said, well, okay, that's how I'm going to format my talk, 2x4. Right, you'll see what I mean. Okay, so I'm going to talk about innovative urban water systems. Start by talking about the water cycle, urban water cycle. You're familiar with this? We get water brought in from the environment, we use it, water gets dirty, conveyed by sewer, out back into the environment. And here in New York City, we get most of our water up in the Catskills. A lot of water come our way, a lot of it leaks. 14 wastewater treatment plants treat the water that's conveyed away by sewers. Massive underground infrastructure systems. There are two things that we want our wastewater treatment plant to do, right? So the first part of the 2x4. The first is to make the wastewater clean, right? You can't compromise on that. So we have the ability through the Clean Water Act and other technologies developed over the years to make our wastewater clean. We can take out all the disease-causing pathogens. We can remove all the constituents that will pollute the environment. Number one. Number two is that there's a paradigm shift undergoing. Is that we want to go beyond just making the wastewater clean. We want to say, we want to mine the wastewater because guess what? There's actually stuff in the wastewater that we can harvest. There's nutrients, there's water, there's energy. Some people say, water is gold, well, wastewater is platinum, right? We don't go a step beyond this. So the second function of the modern wastewater treatment plant, we're not quite there yet, but we're getting there, is that it has to do with resource recovery. We're going to recover water, energy, materials, maybe by scooping it out of the sewer. I don't know, but this is just a graphical depiction. So the other part of the 2x4 is that we're going to accomplish these two objectives through 4 categories of wastewater systems. The first is the traditional sewer shed, one wastewater treatment plant that most systems in the world are today. The second is that we're still going to do that, but we're going to move towards having sewer mining incorporated as part of the system. And then we're going to go to something a little more off-grid with localized water recycling. And then we're going to try to go entirely off-grid. And I'll cover these guys in more detail. So the first is, and I'm below this, here we go. Okay, first is, this very simplified depiction of a sewer system, right? Obviously, it's a lot more complicated than that, but you have the building receiving water, discharging wastewater in there. The wastewater treatment plant will do some level of treatment, and we discharge this. Most of the wastewater systems in the world are like this. It does a really good job of conveying dirty water away from us, which will get us sick, but it comes at a great cost. Wastewater collection pipes are vulnerable. They get clogged up. Fast flowing grease. Wipes are horrible. Tree roots grow in them. They crack. They leak. And we end up with problems like this, sewer overflows. Combined sewer overflows, sanitary sewer overflows. You can see the huge amounts of water lifting 100-pound manhole covers off. So just about every city in the U.S. is under some type of consent decree over sewer overflow. So it really comes at a cost. So we want to rethink, what can we do to improve our sewer systems? And I want to share some examples of vulnerability, down in Florida. So we have a little community, and, one day there was a heavy rainstorm, and their sewer was full. They actually tweeted this out. They said, hey, everybody, stop using the sewer. It's full. Now, I don't know about you. I don't think of the sewer as an appliance. I'll stop using it. But they actually, they're that desperate. So this goes to show you that the system is vulnerable. So how do we help the sewer system out? Well, we can do that first by doing load reduction, right? So lots of ring infrastructure for combined sewer systems, or even separate sewers that leak. Diverting the stormwater from the system is a good start. Ring infrastructure. In fact, New York City just mandated green roofs in April. And the other is by doing some type of local water recycling. Oh yeah, I talked about resource recovery. So one thing we could do is that, let's not think linearly, right? The workshop is sustainable urban underground systems, so subsurface systems, so sustainable. So let's do a loop. Let's bring the water back as recycled water through purple pipes, and many cities do this. But it also comes at another great cost of infrastructure. I mean, you need miles and miles and miles of pipes. Now, imagine trying to do this retroactively. Dig up all the streets in New York, put purple pipes in. Very difficult. So maybe what we should do is do more localized water reuse. We do sewer mining, right? look at where your customers are, your end users are, and put some type of a device, treatment device, where the needs are, and recycle locally. You don't have to build miles and miles of pipes. What technology can do this? Get to that in a second. So, but as part of the resource recovery, let's tie into previous talks, from John and others. We can recover heat from the sewer, right? Thermal recovery, just energy recovery. Previous speaker showed a slide of a greenery inside the subway. Where's the water and fertilizer going to come from? We can recover that from the sewer as well. One technology allows you to do this is the membrane bioreactor, which is basically a miniature wastewater system with membranes. This could be automated, provides really high quality water, and we can make this happen with a membrane bioreactor system. So that was sewer mining. Let's move one step closer. What if we integrate this treatment system within, say, a building? Try to make the building somewhat autonomous, right? And this would be like the idea of a green building. In this green building, water wouldn't be used once; it would be used in cycles. We will reuse the gray water and the black water. One thing to think of is that we still have this umbilical cord on the right, which is basically the building is not. I mean, the MBR is not completely off grid because we still need that for emergency discharge and also get rid of excess biosolids. So it's not completely off the grid, but we're heading that direction. So where you can see this in New York City is at Lower West Side, Battery Park City. There's several green buildings down there, the most famous of which is the Solar building. And this building reuses all of its black water and uses it for irrigation, cooling towers, toilet flushing, a number of things. And it's able to save a lot of the water, reduce wastewater discharge. And the basement might look something like this. You have actually a miniature wastewater treatment system in the building, taking the building almost off the grid. So can we do this? Take the building entirely off the grid, or take the system entirely off the grid? And you say, well, when would you want to do this, right? Won't sewers always be around? Well, guess what? Most of the world does not have sewers. Sewers are very expensive to build, and most of the world still suffers from very fundamental lack of sanitation. And to solve a lot of these issues, you just look at the slums, right? Incredibly high density, congestion, unplanned, lack of ownership of land, very difficult to get sewers in these systems. So we're going to look at South Africa as an example of places we've looked at. So here's an example of a factory that was built, right? And these are all houses you see down here. And months after the factory was built, through time lapse, you can see that people started to move in informally around the factory. And basically, because people want to live close to where they work. And in South Africa, the laws are different. People can actually do this. And then the government has to provide service to folks who live there because it's a fundamental human right to have water and sanitation. How are you going to provide these services to communities that were not planned and seemingly popped up overnight? Well, one of the things they do is to put in these containerized wastewater, sanitary systems, right? Hygiene systems. We have showers, sinks, toilets, urinals. You can put these in there very quickly and provide great service. But unfortunately, these still require sewers. So one of the things that we're doing is to imagine that, what if we can come up with a standalone wastewater treatment system that not only, say, treat wastewater from this system, but will actually recycle the water back, take this whole thing off the grid, work autonomously, right? And so these are the things we want. A lot of the places we go in the world, there's no energy, so it's got to run off the solar or some other means. Well, we're fortunate to get funded by the Gates Foundation through the Reinvent the Toilet Challenge program, and we started doing that. So our idea is to have our system called a new generator, a nutrient energy water generator, coupled with one of these community pollution block facilities. And here's a rough water balance, right? You have basically, say, 10,000 liters of black water that comes out. We'll recycle half of it back for toilet flushing. And, we need some makeup water for human contact water that you might drink and whatnot. And then that leaves 5,000 for something. Well, why not use it for irrigation? In some of the communities we're working in, there's gardens already. Let's repurpose that water for irrigation and create a garden, right? Use water for good. So through a lot of work by students, we had built such a system. This is our awesome student team doing different things. And this system essentially is a self-contained package, autonomous system with membrane and bioreactor. And that we are able to basically bring to South Africa, install right off the truck. This whole installation took maybe half an hour. Dropped it in, connect plumbing. Solar panels went up, and we're up in business. So our idea is that this could be some type of a very rapid, infrastructure that you can bring to communities that need them, bring to emergency situations, humanitarian applications, and basically where sewer building is not possible. And by the way, forgot to mention that Durban estimated that for them to properly sewer an entire city, it would cost billions of US dollars, an asset that they just don't have. So we're looking at this as a possible solution. So IoT was something that also was talked about a lot previously. So imagine having sort of, this mixture of different types of systems, right? This was taken from George Banigus's water reuse book. And basically you have a mixture of, grid systems, off-grid systems, sewer mining, type 4 systems like what I just talked about, all kind of working in concert. And now, unfortunately, as you go from type 1 to type 4, you're going from one system to many systems. So you need to automate all these, right? But we live in the age of IoT, so we can do this. I guess it's the internet of toilets in a way, right? So we can have systems that you can monitor on your smartphone. I mean, the technology is there. We can do it. Okay, so you heard the research questions, right? Since I know, it's an NSF funded workshop, we're supposed to go and have, breakout sessions, generate white papers, fund solicitations. So I just gave a stab at some questions I have myself. I know a lot of these questions already. People are done studies on, written papers on, but I think we just don't know enough yet. For example, as we transition, right, looking towards the future from a Category 1 system towards sewer mining, partially off-grid, completely off-grid, how does it affect the flow of water, energy, materials? What is the right balance for all of this, right? Taking into consideration costs and a number of other things, very localized context. What about the sustainability, vulnerability, resilience of each type of systems? So one of the things that I'm excited about IoT is the opportunities it gives you, but I'm also concerned as heck about cybersecurity, right? So what is the sort of the right trade-off with all these? And that feeds into reliability, maintainability, and costs. So, and then also, are there legal considerations? Sewers, there's water flowing. What if everybody starts siphoning water off of sewers? You're going to get into some type of riparian water rights issues. And, you take it out enough water, I'm sorry, the crap is not going to flow, right? Because it was designed with a certain amount of water in place. So how does that work out in terms of the corrosion and clogging the sewers? Lots of stuff to think about. So with that, I'm going to leave it with this slide. This is a system that we deploy in India. These are 2 standalone toilets at a school, and this is our first prototype. Thanks.
So Daniel, you gave us the cost of some of the sewer system, putting it in the traditional way. So for what you showed us in South Africa, I know it's prototypes, and prototypes are always much more expensive than full production, but what was the cost of that unit?
It was within the project cost. But, I mean, we're looking at these for different scales to be sort of, cost of either, expensive appliances to maybe automobiles, somewhere in that range. But the point is that the user is not going to have to pay for these. The municipality, who otherwise would have to build the sewers, would have these as options.
Mm-hmm. So in terms of a long-term, per capita cost, any idea, a comparison?
Yeah, we're still working on the economics. So one of the things is that you really have to think about life cycle costing.
Sure.
So you can go with something very cheap that has very high OPEX, or you can go with something with slightly higher CapEx but have very low maintenance costs and OPEX. So, that's one of the things we have to look at through this life cycle perspective.
Well, great. Thank you very much.
Thanks.